Okay, we are back and better than ever. We are talking about the scalar product of two vectors. Um, when we multiply numbers ordinarily, we can say, like A and B, we have AB or A times B. We have A squared equals A times A cubed equals A times A. But there are two different ways or two different types of products when we multiply two vectors. There's the scalar product and the vector product. The vector product we don't address in this course, but the scalar product is what we are going to use. We're going to be using it quite a bit. And the scalar product, it results in a scalar answer, a number. And this is the notation v dot w. And most of the time you'll hear it referred to as the dot product. Okay, so and v, this looks like a multiplication symbol, but in the vector world, it's read as cross. It's called the cross product, v cross w. So since there's two ways to get a product with a vector, normal multiplication things, or some of them, don't make any sense, because if we have a vector v and we square it, well, we're not sure what we're talking about. Okay, so that's out of the way. Got a lot of things to talk about. The scalar product of two vectors is also known as a dot product or inner product. I never use the word inner. I never use inner product. I almost always use dot product. If we have two vectors v with these components and w with these components, make sure you understand these. If I have a vector v, then these are its components, v1, v2, v3, and so on, because this part is not on your formula sheet. The dot product, v dot w, equals the sum of the product of corresponding components, as you can see right there. And that formula is spelled out for you on your formula sheet. V dot w equals v1 w1 plus v2 w2 plus v3 w3. Very simple, very easy. Angle between two vectors. So if I have a vector v with components v1, v2, v3, and a vector w with these components, and I move w over to start, so its starting point coincides with the starting point of v, and angle theta is formed. Okay, so the vector across from it has vector, or is negative v plus w, or w minus v. So the magnitude is magnitude of w minus v. That's just simple vector addition. And using the cosine rule, I just put it up here to show you that it's not out of thin air, but you can go through it. It's very simple to understand. We get the other relationship you just saw on your formula sheet. V dot w is equal to magnitude of v times magnitude of w times the cosine of theta, remembering that theta is the angle formed when the two vectors have the same starting point. Okay. And here is the formula in the book. All it did is solve for cosine theta, making it easy to find theta. But on your formula sheet, the formula looks like this. So we have two ways to talk about the dot product, in terms of an angle, in terms of the components, or to find it, or to be able to find an angle. All kinds of things we can do with a dot product. Algebraic properties, it is commutative. V dot v is equal to the magnitude of v squared. But Mr. Becker, you just said you can't square a vector. I'm not squaring the vector, I am squaring its magnitude. Okay. Distributive property is cool, and we can FOIL with vectors as well. That's all that is saying. What else do we need to do? Oops. Let's go back here before we hit an example. The geometric properties. Here are the biggies. Okay. If the dot product is equal to 0, then I know that vector v and w are perpendicular, or orthogonal. Same thing as perpendicular. And it's proved nicely down here. If the two angles are perpendicular, then the angle between them will be 90 degrees. So we've already shown that v dot w is equal to the magnitude of v times the magnitude of w times the cosine of theta. Well, the cosine of 90 is 0, right? So it doesn't matter what the magnitude is, this is going to be 0. So if v dot w equals 0, then the angle, the vectors must be perpendicular because the angle is 90 degrees. We also know that the magnitude of v dot w is equal to magnitude v, magnitude w, if and only if they are non-zero parallel vectors. Okay? Two very important ones. This, in a nutshell, is saying that there's actually two angles between any two, like in Euclidean geometry, between rays. There's actually two angles, as there are with vectors. But we are always going to be talking about the angle when we say what's the angle between two vectors. We're talking about the one between 0 degrees and 180 degrees inclusive, not the greater angle that is out there. Okay. So lots of verbiage out of the way there. We're going to start off by finding the dot product of P dot Q. So vector P dot Q, okay, is equal to the sum of the product of corresponding components. So that would be 2 times -1 plus 3 times 0 plus -1 times 2. And -2 plus 0 minus 2. So this dot product is -4. Okay. The angle between P and Q. Well, I'm going to use the formula from the formula sheet, and you can probably solve it in your head. And that is, what is that? That is V dot W is equal to magnitude of V, magnitude of W times cosine theta. Okay, and then you can easily solve that. V dot W, I mean, you can write it down over mag V, mag W. Sorry, I say mag. That's equal to cosine theta. Okay. So V dot W we already know, that's -4 over magnitude of V, well this is P and Q. So let me change these to P and Q so it doesn't get confusing, sorry. P, Q, P, Q. Okay, so magnitude of P is square root, let's see, 4 plus 9 is 13, 14, so root 14 times root 5, root 5. Okay, and I'm solving for theta, so I'm going to say that's equal to theta. And remember the inverse cos? Okay, and if your calculator is in degrees, then theta is going to be, you crank this in your calculator, theta will be approximately equal to 119 degrees. I'm not sure what it is in radians, but if your calculator's in radians, then you will know. Okay. I think we will stop there, and we'll pick up the videos with a second video. Should be just one more video. See ya!